When constructing confidence intervals for estimating the population mean, mu, we must decide whether to use the standard normal z distribution or the student t distribution. So we would begin by asking if sigma is known. So your first thought is sigma known? You have to read carefully in the problem to determine whether or not they're providing the population standard deviation or if the mention of a standard deviation is referring to the sample. So if the answer is yes, let's see, let me pick another color here. If the answer is yes, then you'll follow the z path that I'm going to put below. If the answer is no, let's pick a different color for no, then we'll follow the t path. Okay, so that's the first thing. Determine whether or not you have the population standard deviation. Alright, let's see what is involved in following the z path. Say you do know that you have the population standard deviation sigma. So for z, then the next question would be, is the population normally distributed? So read the problem and determine whether or not the population is normally distributed. If yes, then you use the normal z distribution. If no, let's pick a different color here. And let me go back and write our decision here. Yes, then we go this way. Okay. If no, then we have another question to ask. Is n greater than 30? Then if yes, we go up here. We do use the normal distribution. Recall that if the population is not normally distributed, but we have a large sample size greater than 30, then we can still use the normal distribution. But if the answer to that is no, then we have to use methods that we have not learned, called use non-parametric or bootstrapping methods. Not in the chapters we're doing right now. Okay, so your first decision was, yes, I do have the population standard deviation. Then I ask, is the population normally distributed? Yes, then we can use the normal z distribution. If it's not normally distributed, but we have a large sample size, we can still use the normal z distribution. But if we continue to say no to these questions, then it's methods that are from another part of the book. Okay. Say we determined at the beginning that we do not have the population standard deviation. So we said follow the t path. Again, we asked, though, is the population normally distributed? If yes, then we use the student t distribution. If no, we have another question to ask. Is n greater than 30? If the answer to that question is yes, we use the student t distribution. If the answer to that question is no, again, we use non-parametric or bootstrapping methods. Let me get my decision here. Yes. Okay, so depending on our answer to the first question, whether or not we have sigma determines which path we take. Let's look at a few examples actually to see how we would use this path and this decision-making process. So we'll just look at just some basic information. So in our first example, we'll say we have a sample size of 15. We have a sample mean of 98, a population standard deviation of 1.2, and we know that the population has a normal distribution. Okay, first question, is sigma known? Well, yes it is. We can tell right here, sigma equals 1.2. That says follow the z-path. Okay, on the z-path, the next question is the population normally distributed? It says it is. It is a normal distribution, so that leads us straight to use the z. So we would use the z distribution. Okay, let's look at B. We have a sample size of 50, a mean of 42, sample mean of 42, sample standard deviation 0.7, and the population has a skewed distribution. Okay, here we would go back. Do we have sigma? No, we do not. So we're on the t-path. The t-path then says, is the population normally distributed? No, it is not. Is n greater than 30? Yes, it is. N is 50, so therefore we may use the student t distribution. Okay, part C. N is 12. The mean is 100. Sample mean. Sample standard deviation is 15, and the population has a normal distribution. Is the population standard deviation given? No, it is not. That puts us on the t-path. Is the population normally distributed? Yes, it is. Well, then that tells us it doesn't matter about sample size. We go straight to use the student t distribution. Even though our sample size is small, we have a normally distributed population. A couple more. N is 12. Sample mean is 98. Sample standard deviation is 2.2. And the population has a skewed distribution. Do we have the population standard deviation sigma? No, we do not. That puts us on the t-path. Is the population normally distributed? No, it isn't. It says it has a skewed distribution. Okay. Well, then is n greater than 30? No, n is 12. That is not greater than 30. So neither z nor t methods apply. Okay, one last example. N is 50. Sample mean 98. population standard deviation 1.2, and the population has a skewed distribution. Okay, well, we have sigma, so we're on the z path. The next question is the population normally distributed? No, it isn't. It says it has a skewed distribution. Then the next question says, well, then is n greater than 30? Well, yes, it is. So that leads us to say that we can use the z. Sigma is known, and our sample size is greater than 30, so it doesn't matter about the population's distribution. Okay, those 5 examples sort of cover most things. The most difficult part is that in the problem you often don't see the symbols for sigma and s, you just have the words, and it's sometimes difficult if you're reading quickly to determine if they're giving you population standard deviation or sample standard deviation. But it's a matter of reading slowly and paying attention to the sentence. If the sentence is mentioning the sample mean, and then the next thing it says is, and the standard deviation is, that's a sentence about the sample. Therefore, they're giving you the sample standard deviation. So it's a matter of reading carefully and following these steps, and you shouldn't have any trouble determining which distribution you should use.